Machines are being developed to convert energy into useful works. Machines have mechanisms for transmission of power and motion. Gears, shafts, couplings, levers, and bearings are essential parts that make various mechanisms. These parts are manufactured by forging processes. Forging is a manufacturing process involving shaping of metal by compressive forces using hammers and presses. Forging is performed at different temperatures. Accordingly, it is called as cold, warm, or hot forging. There are other manufacturing processes for making products like casting, machining, welding, bolting, and riveting. But out of these, forging produces products stronger than any of these processes. In forging, material is compressed and shaped, which allows internal grains to follow the shape of the product, remove porosity, align grains, and thereby forging operations provide in the material strength, toughness, and reliability. Forging industry has emerged as a major contributor to the manufacturing sector of the Indian economy. Forging industry is a basic industry, and such industries tend to grow in a country in relation to the rate of growth of its GDP. We may have many queries in our mind, such as what kind of products are being made by forging?
Well, forgings, being a basic industry, is used in almost every product that moves, that transmits energy, that transports people. So it's used in automotive, it's used in trucks, it's used in railroads, it's used in ships, it's used in power plant equipment, it's used in steel plants, cement plants, sugar plants, anything that uses power.
Power transmission products of forging are crankshafts, camshafts, gearbox parts, shafts, gears, bearing covers, bearings, and levers, pump parts and flanges, couplings and bolts, chain links and hooks. Technologies being used.
The technologies are all the same. I don't think technology has changed too much in this business over the last 100 years. The basic process of forging is to shape metal. What has changed is the equipment that you use to make it. Now it's a lot more sophisticated, very automated, large equipments making larger components. The only change in technology is it's from what used to be art or black magic is become now a science, which is fairly predictable.
Future of forging?
It has a very large potential, both in terms of requirement of forgings and therefore production of forgings, and in terms of our ability to evolve and change technology in this business.
Latest developments in forging?
I think you're going to see more and more automation coming into the industry, more and more technology focused on CAE, more conversion of art into science, more predictability.
Global forging's output in 2010 are quite high as 25.2 million metric tons, while auto component industry occupies a significant value as $1.2 trillion. Estimated share of exports from India is 10%. There are 400 units of forging in India. These units have investments of $3.75 billion approximately, Annual capacity is 3.75 million tons. The composition of this Indian forging industry can be categorized into 4 sectors: large, medium, small and tiny. In our country now, closed die forgings are being produced up to 600 kilograms, while open die forgings are being produced up to 13,000 kilograms. The upset forgings are being manufactured up to 260 millimeter diameter. The ring rolling is being done up to 3 meters. The major share of closed die forging industries are 63%, while open die forgings are 12%, upset forgings 9%, precision forgings 7%, warm forgings 3% and others are 6%. In 2010, open die forging productions in India are 1,685.6, closed die forgings 5,287.8 and seamless ring rolling 1,258.4 metric tons. Closed die hammers are installed up to 16 tons capacity. Presses are up to 16,000 tons. Upsetters are up to 20 centimeters size. And open die presses are installed up to 3,000 tons. Forging industry is a significant employer with employment around 200,000 direct and indirect. The industry was previously more labor intensive. With mechanization, less labor is needed. More than around 58% of the companies in the forging employ less than 200 people. Now, with increasing globalization, the industry is becoming more capital intensive. Let us know the views on some issues like problems of Indian industry and human resources.
Most severe problems being faced by the industry is the lack of availability of personnel who have some basic knowledge at least about the forging technologies and processes. Knowledge of metallurgy is also not available.
Solutions to these problems.
As I said, ITIs are still training individuals on outdated manufacturing processes. They need to change the entire curriculum towards use and looking after equipment that is currently being used in the manufacturing sector.
Now, let us observe glimpses of some of the forging processes in industry. Open die forging is performed between flat dies with no pre-cut profiles in the dies. Movement of the workpiece is the key to this method. Larger parts are hammered or pressed into desired shape and size. Closed die forging is performed by pressing or hammering metal in closed set of dies to get desired shape and size. Upset forging increases the diameter of the workpiece by compressing its length. Examples of common parts produced by this forging process are engine valves, couplings, bolts, screws, and other fasteners. Metal is deformed in cold forging in room temperature. In this process, the material is squeezed between dies. Cold forging is generally performed for soft metals like aluminium. Warm forging is performed at temperature range above room temperature to below recrystallization temperature. Ring rolling is a hot rolling process to increase the diameter of the ring. Ring rolled parts are used in bearings, rockets, turbines, airplanes, pipes, and pressure vessels. Shell forging. These are hollow body forgings produced by forward or backward or their combination. Example is bomb shell. For most prevalent closed die forgings are produced in 5 ways. Die forging. The metal is shaped by pressing or hammering in closed set of dies to get desired shape and size. Blocker type. These types of forgings are semi-finished, which require machining on all surfaces. These forgings are produced with 20 to 30 ksi pressure. Finish only. These forgings are produced with close tolerances at 30 to 50 ksi. The forged parts require minimum machining. Conventional. These forgings are for more intricate and close tolerances jobs with pressure more than 30 to 50 ksi. Near net. These forgings have lighter sections, sharper details, and closer tolerances. These forgings are produced with 40 to 70 ksi pressure. In conventional and near net forgings, blocking type operation is required for finishing the forging. Now, let us see some of the materials being used for forging. The shape and size of raw material and dimensions depend upon the final product to be manufactured. Raw materials are purchased by industry in various sizes like ingots with heavier sections, blooms with cross-sectional area more than 36 square inch, billets with cross-sectional area less than 36 square inch, and plates. There are many metals being used in forging processes, out of which steel and its alloys are mostly being used. Low carbon, low alloy steels are being used for forgings in large extent due to its low cost, ease of processing, and good mechanical properties. Service application areas are up to 480 degrees centigrade. Heat treatment in these materials offers wide choice of properties. These materials find applications in auto components, bicycle parts, hand tool parts, and machine parts. Special alloy steels permit more than 300 ksi yield strength at room temperature. These alloy steels are used in crankshaft, stub axle, connecting rod in transportation, mining, industrial and agricultural equipment, and missiles and aircrafts. Stainless steels are corrosion-resistant materials. These are being used for flanges and valve bodies in food processing, surgical, orthopedic appliances, hospitals, chemicals, and petroleum industry. There are other metals and alloys which are also being used in forging.